Well, let's do a demonstration now of multi-area OSPF. What I want to set up here is 4 separate routers. I want to set them up in this environment. One of the routers that I'm going to use here is my 3560 switch. In my lab environment that I recommend getting 3 1841 routers and a 3560 switch and 2 2960 switches. And with that, it's a little bit messy to do multi-area OSPF with the routers alone. So we're going to use that layer 3 switch as one of our routers. So far, I've put the base configuration on all 4 routers, and I've set up the IP addresses. What I've not done yet is turned on OSPF. So let's take a look at turning on multi-area OSPF, and then we'll examine the routing tables. Right now I'm connected to my PC. This is the PC that is in area 73. So I'm going to open up PuTTY and connect my rollover cable to the console port of router 73. We'll log in here. And one of the things I like to do when I'm configuring OSPF is I like to issue the show IP interface brief command or the show IP route command to determine which networks are currently directly connected to my router. Show IP route is a little bit more effective here because it does show the subnet mask that we need to apply to our network statements in OSPF. When we are working with OSPF, I always recommend only advertising the networks that are directly connected and nothing more. It can cause some very severe problems if we advertise more than just the directly connected networks. Those problems won't exist immediately, but they will exist at some point in the future should you try to add a network to your system and you accidentally type the wrong network address. You can easily create black holes for networks. For the moment, let's move on to multi-area OSPF. So we're going to set up OSPF, router OSPF 10, and all I'm going to do is I'm going to issue my network statements for each network, 10.73.0.0 with the 30-bit mask, and that's going to be in area 73. As a matter of fact, all networks on router 73 are going to be in area 73. Router 73 is an internal router all within the area 73 of OSPF. So for each of our 4 network statements here, they're all going to be in area 73. So we'll do each one of these. Next is 10.73.3.0 with a 24-bit mask. And we have one more here. Network 10.73. Oops, we have to spell network correctly. 10.73.1.0 with a 24-bit mask. So now router 73 is configured for OSPF. We can verify that with our show IP protocols command. And here we'll see OSPF is configured and we're advertising these 4 networks all in area 73. Let's move over to router 1 now. So right now I've hooked my rollover cable up to router 1. I'm going to log in here. And this time we're going to lather, rinse, repeat. And this time we're going to configure OSPF, but we have to configure this area border router. Now, there really isn't anything super fancy to do to configure an area border router. What we have to do is we have to examine our directly connected networks and then advertise the networks in the area with which they exist. So if I do my show IP route here, we'll see I have 3 directly connected networks. One of them is 10.73.0.0, which is my interface that's pointing towards area 73. And then I have 10.0.0.0/30 and 10.0.2.0/23, which are both in area 0 of OSPF. So we'll say router OSPF 10, and we're going to issue our network statements here, 10.0.2.0. This time it's going to have a 23-bit mask, which is going to be 001.255 is a 23-bit mask, and that network is in area 0. We have network 10.0.0.0 with a 30-bit mask, and that is also in area 0. And then network 10.73.0.0 with a 30-bit mask is in area 73. So now we should see a neighbor relationship being built with the router in area 73. Here's our message saying that the neighbor relationship is established and it is in a full state, meaning that we should see some OSPF routes in our routing table now. So if I issue show IP route, now we see the OSPF routes here from area 73. Next, let's go on to our layer 3 switch and configure that device for OSPF. So we're going to log in and lather, rinse, repeat here. We're going to do a show IP route to find out what networks are directly connected, and then we're going to move into config mode and start to configure those. Oh, this isn't the layer 3 switch. This is router 42. Look at that. How do I know that? Well, my host name here says R42. What I can do is just start to configure router 42 here. It doesn't much matter which one I configure first or second. So let's go ahead and do that. So router OSPF 10. This time I'm only going to advertise those 4 directly connected networks to router 42. So, and since router 42 is entirely within area 42, we're going to advertise all 4 of these networks within area 42. So 10.42.0.0 with that 30-bit mask, and that's going to be area 42. We have network 10.42.1.0 with a 24-bit mask. We have network 10.42.2.0 with a 24-bit mask. And I made this previous statement here incorrect, so we'll get rid of this. It's so easy to type area 0 because it's typically the only area that we use in OSPF. But here when we're doing multiple area, we have to make sure that we are conscious of those types of errors we can make, because once we advertise a network in the wrong area, that could prevent OSPF from coming online. So we'll do the last one here, 10.42.3.0 with that 24-bit mask. And I did it again. Wow. See how easy that is to make? I've become in such a habit of issuing area 0 for OSPF. I forget to make it area 42 here. Let's do show IP protocols to make sure that I got it right. And here we're routing for 4 networks, all of them in area 42, which is the right configuration for this device. Let's now go back to my layer 3 switch and configure that device for OSPF. So we'll move into configuration mode. We're going to lather, rinse, repeat here. Do show IP route to find out which routes are directly connected. We'll go into router OSPF 10. We're going to say network 10.0.0.0 with our 30-bit mask. That is in area 0. We have network 10.0.3.0 with a 24-bit mask. That is in area 0. We have network 10.42.0.0 with a 30-bit mask, and that is in area 42. There are only 3 directly connected networks to our layer 3 switch, so that should be sufficient for us to see OSPF with populated routing tables for the entire network. If I do show IP route now, what we see here is we see our directly connected routes as well as our OSPF routes. Now you'll notice that on the layer 3 switch is an area border router between area 0 and area 42. So our networks that we learned about from area 42, since the layer 3 switch is in area 42, these routes show up as regular OSPF routes, meaning that these routes were learned by a type 1 LSA. The 4 routes on the bottom here, these routes are from area 73. They start with 10.73. something something. These are from area 73. Since the layer 3 switch does not have any interfaces in area 73, these 4 routes show up as inter-area routes, meaning that they were learned about through a type 3 LSA. If I move my rollover cable to my router 42, that's router 1, here's router 42. If I move it over here and I do a show IP route within area 42, what we should see is all inter-area routes, except for our 4 directly connected routes. The reason for this is since router 42 is an internal router within area 42, all the routes we learn from OSPF are going to be inter-area because those routes arrived on my router via a type 3 LSA. If I go over to router 73, we'll see the same exact behavior here. Show IP route will show us that all of our OSPF routes are inter-area routes, meaning that we learned about those from a type 3 LSA instead of a type 1 LSA. If I move over to router 1 then and take a look at what I have here, on router 1 we'll do a show IP route. And what we should see here is any route that I learned about from Area 0, namely the 10.0.3.0 network. Here it's showing up as a /32 because that's connected to a loopback interface. Anytime we advertise loopback interfaces, they'll often show up here as a /32 in OSPF because loopback interfaces can only have one single IP address. At any rate, we did learn about that from Area 0. I know that because my OSPF route is not an inter-area route, and any network starting with 10.0 is in Area 0. Since router 1 is in both Area 0 and Area 73, anything I learn about from either Area 0 or Area 73, as we see in these three routes here, are going to show up as regular OSPF routes. Any routes we learn from Area 42 here are going to show up as inter-area routes. If I issue the show IP OSPF database command, it's going to show me my link state database information and how I learned about the different routes. So here it's showing me my router link states, which are my type 1 LSA information. It shows me my net link states, which is type 2 LSA, and it shows me my summary net link states, which are the type 3 LSAs. It does the same thing for Area 73 and Area 0 here.